All right, so we're going to bring in a DXD into our in-lab software. So just like when you're doing a lab case and you have a case in a lab pan, think of in-lab as your lab prescription telling you what you need to do. So it's going to take a minute to load up the software. Sure. Okay, now that we're into in-lab, what I typically do is import DXD files from our Prime Scan or OmniCam into in-lab. So to do that, you click on the three lines in the top left-hand side and click Import. On the desktop of the computer, you can see that we've got a DXD that didn't transfer all the way. So let's go back to our thumb drive, and it looks like we have the proper DXD right here. So we'll go ahead and we'll click Open. If for some reason it's not showing up, make sure you have all cases selected and not just lab 3 shape. Make sure it's selected on all cases so your DXD files show up. We click Open, and this will bring in our patient administrative data. This case was scanned in the CIREC Connect software, which is nice because it'll come in as a blank impression scan. So this is where it's important to communicate with a lab script, or if you're doing it yourself, know what type of product you're trying to produce. So for this patient here, we're going to go ahead and we're going to make a Michigan splint. Okay, we're going to go through 2 different ways to make a Michigan splint or a monoplane splint. One way is through the in-lab software. Another way we're going to do it is through D3 splint module. So we'll go ahead and we'll click Splint in Tray. We'll click on the maxillary arch because that's the arch that we want to make our Nightguard for, and we'll click the chevrons at the bottom of the screen. One thing that we should always do if we decide we want to print a model is make sure that we remove any little area like this over here. This area that I have circled is actually an area that would become unsupported minima in a 3D print. So we want to go ahead and remove that. And the way that we remove these areas is pretty simple. Okay, we're going to go ahead and we're going to right click and hold to drag our model, use our center scroll wheel of our mouse to go in and out, and left click and hold to rotate our model. To actually do a plane cut, we're going to double left click to start, single left click to save our progress, and then double left click to remove that little extra area. All right, so that looks nice, and we don't have any unsupported minima if we were to convert this over to a model to print. And overall, the doctor did a nice job trimming this model right here. We can check our occlusion in this screen. Sometimes you can see here that the patient was biting harder on one side than the other, so their mouth may have shifted a little bit. When I see this, I usually click on this arrow. And we'll try to change our bite so we have an even marking on each side. So we'll go ahead and we will mark this so you can see we have an evening out of our marks. I typically do this for occlusal guards. I don't do this for restorations, especially when a patient's having temporomandibular pain. We'll go ahead and click OK. All right, this is an important step. This is lining it up in the virtual articulator. So what we want to do is put our incisal edge or our mid-sagittal plane or dental midline coincident with this marking on the left-hand side, so our central incisors are sitting directly in these crosshairs. The next thing we want to do is make sure that our canines and first molar cusp tips are lined up on this line. Typically, we like to do it with the mandibular because we're mounting off of Balkwell angle, so we're mounting the mandibular first, but since we can't see it, we're going to use our maxillary canine cusp tip and our maxillary first molar as our reference plane. So everything looks good here. We'll go ahead and click Create our Michigan splint.
Hey,
Okay, so for this aspect, now we've Okay, so for this portion, we're going to go ahead and create Michigan splint. All right, I like to turn off the lower jaw so that way we know that we're going to be working on our active jaw, which is our maxillary arch. We're going to go ahead and re-verify our model axis. Now here, again, you can see in the splint software, it's having us mount our maxillary jaw first. So we're using our canine cuss tips and our maxillary posterior teeth, or maxillary first molar, as our reference. My understanding with the virtual articulating software is it actually should mount the mandibular arch first based off of our balk wheel angle, but that's a discussion for another day. We'll click on Prepare Model. I rarely use this screen. The only time I'd use it is if there was a big error on this tooth right here. Sometimes we'll add a little bit of material due to a scanning error or a cut error on our STL file. But typically I don't use add, remove, or smooth in this phase because the prime scan, generally things are pretty smooth. This is our insertion axis. So as we're doing this, we want to make sure we have an insertion axis that is amenable to removal by the patient. So typically you think this is the patient's maxillary jaw. We want to have a slight anterior angle to our insertion axis to simulate how the patient is going to be putting this restoration or removable device into their mouth. I don't like to have a ton of undercuts on my anterior teeth. Something along this line should make it very easy for the patient to take this on and take this off. I leave my undercut clearance at 200 microns. If you find with your 3D print that that's too tight, you can always move this. I typically leave it as the factory default. We'll then click the chevrons at the bottom of the screen and put on our blockout material, which we currently have. Okay, we now have our blockout material. We're going to go ahead and turn off the lower jaw. We're checking our blockout. You can modify it in the screen. Very rarely with the prime scan do I find that I have to modify my blockout. People are different, and some people really like to modify it. I typically leave it alone and just draw my line a little bit differently. So with this patient, they were taken in a maximum intercuspation bite, not a CR or open bite. So if it's taken like this, the way that we would adjust it is by going to open jaw, and we're going to open our pin about 4 millimeters to start and do a visual inspection in the posterior to make sure that we have approximately 2 millimeters of opening. Now in this screen, it would be really nice if we could add maybe a distance setting to actually look at the analyzing tools to check it. Unfortunately, we don't have it in the software yet. In D3 Splint, we actually do have the ability to check our pin opening and posterior clearance. In my opinion, this is going to be a little thin back here, especially for a TMD patient. I like to have 2 millimeters of separation. So what we're going to go ahead and do is we're going to actually go ahead and open this up just maybe about another millimeter to get maybe another 0.5 millimeter or 1/4 millimeter in the posterior. So overall, I'm happy with that. We're now going to go ahead to create splint. The way I like to create splints is by creating it by line. So I actually draw where I want my splint to start and my splint to end. So usually I don't engage a lot of buccal contours on my teeth, because what that usually ends up meaning is that I'm going to be doing a lot of adjusting to get this to fit comfortably in the patient's mouth. Where I pick up all of my retention and resistance form is actually on the lingual arch. Let me go ahead and turn off the lower jaw here. Let me redraw this line. So single left click to save our progress, double left click to join our lines. Now this is too much on the lingual, so I'll go ahead and make a little adjustment, especially in this anterior rugate area. I want a little bit of a lingual kind of landing pad, so that way when we do our adjustment, we have room for our mandibular anterior teeth to rest. So overall, this is how I like my splint design to look. Generally, they snap right in with very little adjustment. We want to go ahead and create a round transition, and we want something called plane occlusion. This is kind of a new addition to the splint software, and the advantage to this is now we can turn our mandibular teeth on All right, so we are talking about the plane occlusion. So with the plane occlusion function, the nice thing that we can do is we can drag this down so we have intersection on all of our posterior teeth. I typically don't mind if there's more intersection in the posterior because we're going to go ahead and do a virtual articulation to get rid of a lot of our excess material. So I'll typically drag my plane occlusion down below all of the contact points of my teeth. She's got a relatively deep curve of spee, so that deep curve of spee makes me have to drag my occlusal plane down a little bit further. We'll go ahead and we'll click apply, and you should see it add my splint material thickness to this plane line right here, which is what we have. We'll now go to the next screen, and I go through a pretty normal process. First thing I'm going to do is I'm going to turn off my lower jaw. I'm going to click on form. I'm going to rotate my model, and I'm going to just right off the bat add with 100% strength and the largest tool that I have a little bit larger lingual ramp. Okay, that way we have a nice spot for our mandibular anterior teeth. The next thing we're going to do is click consider jaw. What that's going to do is any area of the plane that we've exceeded, it's going to go ahead and make a little tooth mark. We'll then turn on our contacts. From there, we'll go down further. We'll click articulated grinding, and you can adjust this based off whatever articulator you have. So if you're using a whip mix, you might do 110 and 110. Okay. If you're using a Stratus, it might be a little bit different, depending on your occlusal theory, whether you believe in Monson's spherical theory or some other type of occlusal phenomenon. You can make adjustments from there. Typically, I don't mess with this too much. But if we do mount it on a whip mix articulator, I'll usually change it to 110 and 110. We'll go ahead and we'll click apply. There's actually some pretty recent literature that came out that looked at fully adjustable articulator, average value articulation, and non-adjustable articulation for occlusal devices, and they found that patients perceive no difference between all three of them. So I know you've probably taken very expensive courses to learn different occlusal theories for splint design. Fact of the matter is, when we look at research, it's not really supported that you have to do one splint design or another. Okay, so from there, what I'm going to do, and this is one disadvantage of the software, is you have to smooth all these areas out. So again, we go back to the smooth tool, largest size, largest strength, and we're going to smooth all these little divots out. Okay, as you see us smoothing it out, you can see that we're getting more of a monoplane design. And a lot of our green is starting to show up. Now you got to think we're looking at this maybe 15 or 20 times larger than what we would see in the patient's mouth, but still I want to have it as flat as possible. So then from here, I'll usually take my remove tool, remove it one more time, all right, let's get rid of this, and then hit smooth one more time. And now this should give us a relatively smooth surface with an even number of contacts per side. Now, I'm going to work a little bit harder in the posterior because I don't like heavy posterior contacts. I'd much rather have a little bit more anterior contact, just because we know that a little bit heavier anterior contact is going to remove the amount of pressure that we can apply to our masseter muscle. And we should have a reduced masseter activity if we have a heavier anterior contact and lighter posterior contact. So I try to go through and make my dots in the posterior a little bit smaller and try to leave my anterior just slightly heavier. And if we have to make adjustments, it's easy to make those anterior adjustments in the mouth. I'm going to add one contact on this molar here. There we go. And then, just to be on the picky side, we'll go ahead and make these a little bit lighter and smooth out one last time. And this is my basic occlusal design for my monoplane splint. But from there, we're pretty much done with our splint design. So what we want to do next is we want to go ahead and we want to export these models as an STL file to our desktop. And from here, what we'll do is we'll go ahead and we'll go into D3 Splint and make a based model, and we'll make an occlusal device. I tend to find D3 Splint is a little bit faster. It's just graphic user interface isn't quite as friendly. So the way that we do this is we go, once we're at our model screen, we'll then go up to our 3 points up here and click export. Once we've gotten to this model axis screen, it's going to export STL files that are properly articulated to each other and in space. So we're going to go ahead and select highest resolution STL, and we're going to export our test case to our desktop. All right, so this I think is, to me, the best and easiest software to use to install on your PrimeScan or your OmniCam, and this is called D3 Splint. We have it saved as splints only, but in actuality, I just put this on here for our assistants and our staff so they know what we use this software for. You can actually use it to base a model and print from a 3D scan very, very easily. So the way we do it is double click on this, and this is an application developed for the Blender software. Okay, so this is actually really neat. We're going to go ahead and just X this out. It's telling us that we have our 3D view D3 Splint module. Okay. Unfortunately, because this isn't validated with any resin specifically, you have to click the Not for Clinical Use button. At the end of the day, I'm not an FDA regulated lab, so I really don't care all that much. I'm not selling these to other labs. So using this software for a validated resin is super easy, but the software workflow itself has not been validated for the fabrication of FDA regulated devices like sleep apnea or surgical guides. So I use it only for TMD splints. This is a very, very robust software you can use for a lot of things. What I'm going to do first is import a model and show you how easy it is to base a model. So once you do your scan in PrimeScan, you're going to trim your models just like we did in InLab, using your cut function and edit model function to trim all of the minima away. And then we're going to import an STL model. And the way that we do that is we just click on Import, Desktop, and let's just click on the upper jaw to bring it in as our test case. You can see from here that we have a trimmed model imported as an STL directly from our PrimeScan. Now this software I install on the D drive of my PrimeScan and just have a shortcut to my desktop, so that way I'm not chewing up valuable space on my C drive. So once we've imported this model, we're going to come all the way down to the bottom, and if you see, it gives me base and thickness operations. We're going to go ahead and click on Simple Base. From Simple Base, I leave this set. I like to have about 2 to 3 millimeters of base thickness when I'm making a removable device, and we'll go ahead and hit OK. On your PrimeScan, this is a very quick process. The only thing that I recommend in order to translate a model, and I'll show you that in a second, you need to have the shift function of the keyboard. One of the best ways to do that is to buy a gaming mouse that has programmable buttons and program one of your buttons to be the shift key on your mouse, so you're not reliant on the keyboard of your PrimeScan to do this operation. So it doesn't take super long. It takes maybe, I don't know, 30 seconds or so if you've got a really nice trimmed model. And you can see this is a print-ready model directly from the PrimeScan. I find this is faster than most companies' embedded basing softwares. So if you see me rotating the model is holding my center scroll wheel on my mouse to rotate the model around, okay? To translate the model, we have to hold the shift key, click and hold our center scroll wheel of our mouse, and now we can translate this model around, okay? To zoom in and out, I'm scrolling the center scroll wheel on my mouse. And to rotate it, I'm clicking and holding only my center scroll wheel. And again, to translate, shift, click and hold my center scroll wheel, and now we should be good to go. Okay, so from here, what we're going to do is we're going to go ahead and export this model by hitting File, Export, STL, and now we'll go back to our desktop and we can put this as Final Model. And we'll click Export. This is so much faster than using Formlabs 3D printing software to base your models. I'm not sure about SprintRay, how fast that software is, but 30 seconds or so for this software is very, very quick, and it always gives me a nice printable base with no unsupported minima if I have my model trimmed properly. Now, we've already got this model done. Okay, so from here what we can do is we can import STL models again, and we're going to go ahead and import just our raw STL models. We're going to click lower and upper, and you can select both of them by holding the shift key when you click, and we're going to import both of our models. All right, so now we have our models selected. I'm going to go ahead and turn off our based model so that way it doesn't get in our way. And we're doing that by just clicking this little visualization icon on the right hand side. Now, the nice thing if you're training an assistant to do this is there's little check boxes. Okay, you're only going to follow the check box areas. So we're going to click on this. There's no check in the box. So we're going to click on our splint model and left click. Okay, now you see it says set opposing. We'll click on the mandibular arch. And now we're going to set our landmarks. To set our landmarks, there's two ways you can do it. You can either memorize your landmarks, or you can look at the instruction tab on the right hand side. So it says molars first, incisal edge, and maxillary midline. This is going to be how we orient our models on our articulator. Okay, so now we don't have to change articulating values, but what we do have to remember is we did take a bite that was closed. So we do have to recover or change our settings. So we're going to click on change pin settings. Just like in the InLab software, I start with 4 millimeters. Okay. And to change that, you left click and hold and drag. Okay. We'll click OK. And now I'm going to check my clearance. I want to have about 2 millimeters, 1.75 is totally fine. And you can see that opening this model doesn't give me a lot of clearance. So I actually have to open a little bit more. So we're going to change our pin setting and open 1 more millimeter. Okay. You want to make sure that when you click on this software, you open up approximately a millimeter at a time after your initial opening, because if you actually hit 4 millimeters again, you're now going to open the model 4 more millimeters. So now you can see we have 6 millimeters of anterior opening, and we're still going to have one little interference in the posterior. So that's okay, but we just have to know that we're going to have to maybe make a little adjustment, or we may have a little bit of a thin spot on our occlusal device. All right, we're now going to survey our models. We're going to go back to our checked boxes. You can avoid all of that as the doctor for your staff by taking a open bite record, but that's really up to you. I prefer maximum intercuspation records just because it's easier for my staff to take it without me being there. This is our insertion axis again. So just like in the InLab software, you want to have a slight anterior insertion. And usually I know that by me seeing a little bit of my anterior teeth. Okay, so that should be my good anterior insertion. We'll go ahead and we'll click capture view, and we'll click commit. Okay, from there it's going to go ahead and survey my model with my undercuts. All right, we then have to click on the save button down here in the lower left hand corner. You don't have to save anything special. This is what's called a blend file. Just click save as blend file. It'll keep overwriting that same file, not a big deal. We never use that other than for the continuation of the software, so don't worry about naming that something special. Okay, we then have to click on our next box as refractory model, and I like to have my undercut set at about 110 to 200 microns, just like I have in the InLab software. So you can adjust that right here. We'll go ahead and we'll click OK, and now it's going to create my blockout model just like it did in the InLab software. Okay, so now we're going to go ahead to our next checkbox and click Mark Splint Outline. Okay, so to do this, there's multiple different ways. I like to hold the Shift key, left click and hold, and I like to just drag the line through. Okay. You can also click one point at a time if you really prefer to do it this way. Some people really like to do it this way. It really doesn't matter to me. I just find it quicker for me to drag like this, okay? I'm then gonna, just like in the InLab software, give myself a little bit of a lingual landing space, so that way I can pick up my mandibular anterior teeth, get our points close, and then we're gonna click Connect Endpoints in the lower right-hand side. From here, we can adjust each individual point if we find that we're too high in one spot. But again, I don't really want to engage a lot of my undercuts. I tend to find when I make these, the biggest area of complaint is patients always say they're tight on the front teeth. So I don't really engage a ton of my front teeth if I can help it. Try to engage the least amount of undercuts possible. So we'll go ahead and click Next. From here, we've got our endpoints connected. And now you'll see that we have a little eyedropper that shows up here, okay? So for eyedropper, what we're gonna do is we're gonna click on the interior region of the splint with a left click, and it should highlight for us. Color does not matter, okay? So now this is where it's going to grow our splint. All right, from here, we'll go ahead and click Next again. And now you can see that it checked our splint outline mark. From here, we're gonna click on our splint shell. Depending on your printer, I usually like to leave it at 1.5 so that way I don't have any print errors. It's going to go ahead and create my print shell. You then click on the next checkbox for minimal thickness. Again, I don't want to get any thinner than 1 millimeter just because my printer has a hard time with anything thinner than 1 millimeter when it comes to these clear materials. I'm now going to mark my occlusal curves. All right, so the way that we're going to do this is we're going to go ahead and mark our mandibular range of movement is going to be on the outer edge or incisal edge of our maxillary teeth. So this is where our wax rim of our tray is going to go. It's going to extend for mandibular border movements beyond my maxillary buccal cusps or incisal edge. We mark our mandibular teeth where our maxillary jaw is going to go during working and non-working movements. We're going to mark the lingual boundary, okay? So that way we pick up working and non-working movements. Now from here, if you really want, you can move this information up. So that way the computer doesn't have to remove a lot of data. But overall, I think this is generally a pretty good position. Okay, I usually don't mess with this a ton. Usually I make my adjustments and then I'm done. If you really want to get picky about it, you can adjust your curves for thicknesses. I don't spend a lot of time on this because I don't notice a huge difference from monoplane splint. So generally speaking, this is pretty good, okay? So you want to make sure your maxillary is set on the buccal cusps, mandibular is set on the lingual cusps. We'll go ahead and we'll click Commit. From there, here is our opening. We'll then click Wax Rim. We'll click OK. Leave your settings alone. We'll now fuse our rim to our shell. All right, the only box that I click down here is block out large concavity. That's going to take care of this little area right here where patient's tongue could find that area and find it really annoying. So we're going to block out our large concavity. All right, from there, it's pretty easy. We then go down and we mark our posterior contacts. From monoplane splint, we're going to mark our anterior contacts too. So you just, every buccal cusp on the mandibular arch and incisal edge, we're going to mark, okay? And you're going to keep marking points until you start to have this red appear, okay? If it doesn't appear by the time you mark all your buccal cusps, start going on your lingual cusps. This is a monoplane splint. So the more points we give it, eventually this red will always show up. This is how it's going to determine what it has to subtract from our wax rim. Okay, so anything that intersects is going to be subtracted. So we'll go ahead and we'll click Commit. If you follow over here on the left-hand side where it says Subtract Posterior Plane, we're just going down our checkboxes. Okay, so we're going to go ahead and subtract our posterior plane. Now we have a really nice monoplane splint, but we haven't ran it through a virtual articulator. That's what we're going to do right here. We're going to go ahead and generate our functional anatomy. So I leave this preset based on the articulator. Earlier on in the software, if you want to make adjustments to your articulator, you can. Again, I don't really adjust the presets all that much because for a monoplane splint, I notice very little adjustments with the preset articulating values. So overall, it's going through all of my lateral obtrusive, mediotrusive, protrusive movements to give me a really nice monoplane type of anatomy. Now again, when I'm doing this quickly and not talking at all, this generally takes me about 5 minutes, maybe 7 minutes on the prime scan. I have a little bit slower computer I'm working on right now, so I have my screen capture software on here so I can make this little video. So we're now going to subtract our functional surfaces, and now we have a really nice monoplane splint. From here, you can be done, right? So some people at this point will go ahead and they'll finalize the splint. What I like to do is click this grind maximum intercuspation function to subtract those little areas where it was a little bit heavy, okay? And so you can see how it now has these little tooth marks. I'll click remesh smooth. Usually twice we'll do it until I have a really nice smooth monoplane surface. And then I'll finalize the splint. Now the solver I like to use is called bimeshed solver. So anywhere there's this intersection, it'll subtract the intersecting of the two meshes. So we'll go ahead and click finalize splint, bimesh solver, and click OK. You can preset it as well. I think you can hit file, save, and you can save it as a preference. So on my prime scan, it's actually saved as a preference in there. But there we go. There's our occlusal splint. We're going to go ahead and export that. And we're going to go ahead and put it on our desktop, and we'll put it as our test case splint. Now in this software too, you can also emboss a label, add a label, just like we did in the in-lab software. I tend to find that when you add labels and try to get fancy, what ends up happening is you have to add more supports. Okay, so from here, we're going to go ahead and close this down. We'll then open up our preform software and toss it on our 3D printer. Again, the preform software and D3 Splint both run no problem on a prime scan or an OmniCam running Windows 10. I've had 0 issues. I actually installed both of them on the D drive and have shortcuts on my desktop. So from here, what I'm telling the computer is I want to use Dental LT Clear. I'm going to use version 1, and I'm going to be at 100 microns of print. The easy thing here is we drag it in. We're going to go ahead to our desktop, and we're going to click on our test case. Okay, you can see we now have our splint dragged in. We're going to rotate it. Now on my printer, because it is a SLA laser type printer, if we put it on the mixer side, typically we get a faster print. The other kind of little tip or trick I like to tell people is always put the incisal edge down and try to put it a little bit of an angle and the heels up. So that way when it's printing, you start with one solid piece, and as you go towards the posterior, you're growing 2 separate sections. If you have it the other way, you start printing with 2 separate sections and then have to join in the anterior. That's where I notice it tends to fit a little bit tight for my patients. The next thing we're going to do is we're going to go ahead and add supports. Okay, so I like to have my touch point size be as small as possible. So I found that 0.3 to 0.35 is the smallest touch points I can get. I typically do a mini raft, and I hit auto generate supports. I let the computer decide what it wants to add, and typically they're pretty easy for me to clean. So overall, here's my 3D print design. You can see it passed all of its printability tests, and it's about 1 hour and 15 minutes to print this splint. Now, if we are going to go ahead and print this, right, and I added more cases, let me see if I can drag this around here. I could probably add, maybe 5 more Nightguards, and my time isn't going to go up substantially, maybe 45 minutes if I fill up the printer bed with 3D prints. From here, we're going to hit File, Print, and upload our job. And from there, I'll go ahead and show you a video of how I separate these and mark my occlusion.
Okay,
So now for this portion here, let me make sure I'm in view so you can see everything. All right, so here is my 3D print. Okay, so when I go ahead and actually separate these off of my build platform, I take this little tool here. Let me see if I can get a good shot of that here. And we start to separate. All right, so that is a way to do it if you want to be very, very exacting with removing them. Another way that you can do it, and I find is a lot faster, is to take a diamond cutoff wheel and just go around the diamond cutoff wheel, being very careful and breaking our little touch points. So that's what I'm going to do. Okay, now that I've separated about half of them, I should be able to twist off the rest. There we go. So now what we'll do is we'll take what's remaining and just kind of flick them off of there. All right. So now from here you can see that we're left with all these little pieces. So how do I adjust these? Well, there's a couple different ways. I really like this wheel right here, one of these little Scotch-Brite coarse wheels. And I'll take this and start adjusting all these little points off of here without actually using my acrylic grinder. Now you can see it's a little rough, but we'll use our medium or fine Scotch-Brite and do the exact same thing. This will smooth it out a little bit more for us. All right, so now you can see it's much smoother, still a little bit maybe on the rough side. So how do I take care of that? Well, there's a couple ways. One way is you can do the conventional method of taking this to a pumice wheel, which we have over there. Or you can take a paintbrush with a little additional resin and dunk it in your resin tank, paint this, and when you cure it occlusal side up, okay? I typically don't do that though, all right? What I like to do is I actually like this surface to maybe be a little bit on the rougher side as I'm curing it. And then once I get my occlusion adjusted how I want, I'll use maybe not the pumice wheel, but I've got a high shine wheel,
and just give it a little slight buffing. But at this point, if it's got a little surface roughness to it, it's easier for me to mark my contacts intraorally. Generally speaking, I have very little adjustment to make in the mouth when I'm using my Scotch-Brite wheels, removing our little supports. Now, in order to prevent this from being tacky, you can see I just used some canola oil spray. Let me see if I can hold it up here. I don't want to spray my in-lab computer, but we're going to do a quick spray. So now, we've got it all sprayed down. We're going to just kind of wipe it in with our gloves. I'm going to apply just a little bit of air. All right. We have a nice shiny surface. And now, I'm sure we still have to cure this, even though it looks nice and shiny after our canola oil. Put it into our 3D printer curing oven. I like to cure it for about an hour if I'm doing a big batch of them. So let's do it, pretend like we got the whole batch. Typically I'll try to save these. So I'm doing multiples at a time, not doing one at a time. If I've got a CAD/CAM patient in the chair for a big rehab, or we're doing even just a bunch of anterior restorations, I'll actually start making this. I'll virtually seat my restorations on my model in InLab, export that model as an STL, and then make my splint in D3 Splint. And so I can be doing this process while I'm getting those restorations seated. When I do that, I typically bump up my my blockout and offset values a little bit, just to make sure if there's a little bit of variation in seating the restorations, it still seats properly. But from here, we're going to go ahead and we're going to preheat. And that is how I process a occlusal splint from start to finish.